instructions for the binary to decimal to hex assignment can be found in the assignments area or in the syllabus area of your Canvas course site. I'm going to run you through the project here, and then I'm going to actually walk you through how I solve this and use the assignment really as a teaching opportunity to discuss several things and reinforce some things we've already talked about. In this project we have 8 buttons that represent the 8 different bits of a byte. And that byte, of course, as we've seen, can range from value from 0 to 255 when converted to decimal. We can set these bits by simply clicking on the button, and as we do so, it shows us what the equivalent decimal value, what the equivalent hexadecimal value is, and what the character would be represented by this ASCII value with the Arial font. The characters will vary from font to font, so I just chose Arial. And all of these change automatically as we adjust the bits. So we've seen before in a previous video that a value of 65 is a capital A, and the value of 66 is a capital B, and if we go to a 98, that's a lowercase b, and 97 would be a lowercase a. Each of these 8 buttons are responding to the same event. Let's take a look at some of the things we'll cover in this project. In this project, as I said, we're going to handle multiple events with one method. Each of those 8 buttons will turn color from the turquoise to yellow based on the value, and will also generate what the equivalent decimal, hexadecimal, and ASCII character is. Within that method, we're going to use an if-else to look at which button was clicked and determine what color it should be and whether the text should be a 1 or a 0. And we'll just use that as a toggle. We'll also use sequential if structures in creating the decimal equivalent. And after we've gone through this, I'm going to show you another way to do this with ternary conditionals as an option. We've looked at ternaries in the past. I think it's a little bit cleaner using ternaries, and ternaries might impress a prospective employer if you use them correctly. We'll use a switch structure in converting between the decimal and hexadecimal, and then a substring also in extracting the character from a string. And then finally we'll use the decimal value and use a char conversion to convert that to an ASCII character. So with that, let's take a look at Visual Studio. So I've already created the project, and rather than watching me develop everything and type in my code, I'm just going to walk you through my solution. You can pause as you recreate this. You will submit this for a grade, and this is a great opportunity to pick up some easy points because I'm going to do the thinking for you on this one. So I started by creating these 8 different buttons. These are named BTN 128, BTN 64, BTN 32, BTN 16, BTN 8, BTN 4, BTN 2, and BTN 1. Of course, those numbers correspond to the value of each of these bits. I set the back color of all these to a medium turquoise. And I'm using a flat style, flat appearance of flat. I used a very large font and set the text of each of these to 0. We're going to start with these all being 0. And then I just put some labels underneath here of the bit values going from 1 to 28. You could actually do that as one long label and just space it. I did it as 8 different labels. And then I've got a label to the right of this, which I named LBL decimal. The text of LBL decimal contains an equal sign, a space, and a 0. Make sure it's wide enough though that you can get 3 digits here. So you might just even want to start this out as, just to make sure you get the right size, of equals 255. That'd be our maximum value. But when we run this, we wanted to start with equals 0 so that it corresponds to our 8 0 bits. Then I put a label of decimal under it. I basically did the same thing for hexadecimal. This one is labeled LBL hex. And then the last one is LBL char, and I put a label under that of char and in parentheses Arial. That is our interface. You might want to pause here and create that interface, and then we'll go into the code. So each of these 8 bits, I went into the events section of our properties panel, and I had selected all 8 of these, and created a method called changeBit. And pretty much everything we do occurs in that one method. So let's take a look at that method. I'm just going to double click on one of these. So here's my changeBit. Since we're handling multiple objects, I want to take sender, and I'm going to cast sender as a button. I'm just going to name it bit, the type button. So I'm guaranteeing here that sender is a button. The only objects that use this piece of code are all buttons. And then I have an if structure. And I simply created a toggle here. If the text of bit, whichever one of those 8 buttons we create, if it is 0, I'm going to change it to 1 and change the color to yellow. Otherwise, I'm going to change the text to 0 and change the color to medium turquoise. So that little simple if-else structure creates a toggle situation where we can go back and forth between 1 and 0. Now, as those values change between 0 and 1, we want to calculate the decimal equivalent. And that's what I do next. So I have an integer value called dec equals 0. And then I'm going to check to see, is BTN 128 text, the text of that button, is it equal to 1? And if it is, I'm going to increment dec by 128. Then I'll check and see if the 64 button text is equal to 1. If it is, I'll increment that by 64. And so forth, 32, 16, 8, 4, 2, and 1. And then all I'm doing is showing that value of dec converted to a string, preceding that with an equals space in concatenation, and displaying that in the LBL decimal.txt. Next, I want to look at hex. So now that I know the decimal value, I can figure out the hex value. So our hex values, of course, for 1 byte are 2 digits. So I have hex 1 and hex 2 both as integers. I set them both equal to 0. I created 2 variables which are going to be my hex 1 display. I wanted these to be strings because in this case, the hex values won't necessarily be numbers. They could be letters. Remember, our hex values, or our hex digits, can go from 0 to 9 as well as A through F. So to find the hex 1, which is the number of 16s in our hex value, I'm going to divide or do integer division of dec by 16. Both these are integers, so it's going to give me an integer division, and place that in hex 1. And then I want the remainder. I use the modulus operator here. Hex 2 equals dec mod 16. Now I want to create my hex 1 display and my hex 2 display based on those 2 values. And here I use a switch. So I'm going to look at hex 1. If hex 1 is equal to 10, I want to display an A. Or if hex 1 is equal to 11, I want to display a B. Hex 12, I want to display a C. 14 is an E, 15 is an F. And if none of those are true, it's 0 to 9, I'm going to display it as a string of the numeric value. That gives me my first digit. Now, that's a very, very acceptable way of doing that, but we've got quite a bit of code here. I want to show you a different way to do the hex 2. So for hex 2, I created a string going from 0 to 9 and A, B, C, D, E, F. Remember, indexes start counting with 0, so index 1 is 1, index 2 is 2, and so forth. All I need to do then is take the substring of that string called hex values and pull out whichever character I want, which is my value of hex 2. And I'm getting 1 character. So if it's a 10, it's going to give me an A. If it's a 15, I'm going to get an F. And if it's a 4, I'll get a 4. If it's a 0, I'll get a 0. Now, I could very simply have done the exact same thing with hex 2, and I could get rid of that whole switch structure simply by changing hex 1 display equals the substring of hex values. I'm going to start with the index of hex 1. With that, I could actually get rid of all of that switch structure. Either way would work. And of course, I could use the switch structure, copy and paste that for hex 2. This is a nice, clean way of doing it. And you probably wouldn't necessarily think about doing it this way without some additional experience and thinking about how do I make this more efficient? How do I reduce the amount of code? So my label text then is simply LBL hex.text. Again, I'm going to concatenate an equal space, and I'm going to concatenate hex1 display and hex2 display. So if it's 255, that'll give me an FF. If the number is 8, it's going to give me a 08. And then to display the character of our Arial font, I can take LBL char.text. I'm going to do the same thing, concatenate equals space, and I'm going to add to that the dec value converted to a character. So a character, it's sort of like a string, it's just one character at a time. So if we run this, there's my 128, which would give me a value of 80 hexadecimal. It's not a printable char in this case. Let's go back to our A, capital C, capital B. There's our D, our E, our F, and so forth. When I make these lowercase, I'm just going to turn this 32-bit on, and those become lowercase. So if we think about 64 as a value, let's go back to the 65. 64 is 4 16s. And I have a 1 in the ones place. It gives me a 41. And if we go all ones here, of course we're going to get 255 and FF and our Y with the, I think it's called an umlaut accent. And going back to 0, of course we'll get zeros. So that all works. I'm going to change my code a little bit more to show you another way to do this using ternary operators. So I'm going to close my application. So where I have this whole if structure, I can change each of these ifs to a ternary statement. And I'm just going to select these. I've already typed in my statement. I copied it. I'm just going to paste it so you can see what this would look like. A little bit cleaner, a lot less code. So let's walk through each one of these, or walk through a couple of these. Dec, originally set to 0, I'm going to increment it by 128 if btn128.text equals 1. And that's a string. So remember, ternary statement equals, in this case, a variable. And you're going to do equals. In this case, I'm incrementing it, so I'm going to do plus equals. My condition that I'm looking at, a question mark, the true value, a colon, and the false value. So that's the format for our ternary conditional. I just basically do the same thing for all the others. So a little shorter code. Now I could have done the same thing up here, but because I'm doing two different things, I would write two statements. And just to show you what those would be, we're going to say bit.text equals, and here I'm going to look at bit.text. Is it equal to a 0? And if it is, my true value will be a 1. We're going to convert that. Otherwise, if it's already 1, we're going to convert it to a 0. Okay, that takes care of these two bits. But now I can also change the back color. I'm going to bit.backcolor equals, and I'm just going to copy and paste this. And rather than changing this to a 1, I'm going to change it to color.yellow. And this last one I'll change to color.medium turquoise. And I need a capital C here on the back color. So now what I've done is I've replaced that structure with those two lines, two ternary statements. And I probably should check and make sure this still works, but look at how short our code now is for converting the binary values to a decimal, to a hexadecimal, and displaying the character. Let's see if this still works. So what I'm not getting is the yellow. Come back up here. And the reason for that is this is changing the values. So what I really want to do is swap these two, because these are now going to be the opposite. Because this statement changes the value from a 0 to 1, but here we're seeing if it's a 0, we want to change it to yellow, when really if it's a 0, we want to change it to medium turquoise. And then we want to change this one to yellow. Now I did notice I was getting a little problem here with the btn1. That's because in my copying and paste, that should become a 1 value rather than a 2 value. The 2 value put it outside the range of what we should be doing. So now let's try this again. Now the colors are working, and I go up to 255. Let's go back to the capital A, and there's our capital A of 65 decimal and 41 hex. So everything is working, but we now have very short code to make all this work. It makes it look that much more readable. As I said, if you're providing a portfolio to a prospective employer, if they see that you know how to use ternary operators, that might score you a point or two. It simply makes the code a little bit easier to digest and read for an experienced programmer. That's our project. Go ahead and complete this, test it, and make sure it works from 0 to 255. You don't have to test every single value between those, but test a few in between, like do the capital A as 65, do a 0, do 255, and then zip it together and submit it for your grade.